Hello, so in today's video, we're going to prove another trig identity similar to what we did in yesterday's video. So in yesterday's video, if we just go back here, we prove this formula here. So we prove that sine theta is 2 tan theta over 2 divided by 1 plus tan squared theta over 2. We proved that yesterday. So today's going to be about proving this one. So writing cos theta in terms of tan theta over 2. So you get this formula here, and we're actually going to prove that this formula works. So it's a very similar process to how we did the proof yesterday. So we're going to start with our right-hand side to prove this one. So we're going to start with that. So 1 minus tan squared theta over 2 divided by 1 plus tan squared theta over 2. We're going to rewrite the tan theta over 2 as sine theta over 2. So this can be 1 minus sine squared theta over 2 divided by cos squared theta over 2. And then this is all divided by 1 plus sine squared theta over 2 divided by cos squared theta over 2. So now we can do a very similar trick to what we did in the previous video yesterday. So we can times everything in this fraction. So that term, that term, that term, that term, the 4 terms in the fraction by cos squared theta over 2. So if we do that, 1 times cos squared theta over 2 just becomes a cos squared theta over 2. And then copy the minus sign. Then this fraction times by cos squared theta over 2. The cos squared theta over 2 just cancels out. So you're just going to be left with a sine squared theta over 2. And then you can divide that all by what you get when you multiply the number 1 by cos squared theta over 2, which is again cos squared theta over 2. And then plus sign. And then this fraction times by cos squared theta over 2. That's going to give us just a sine squared theta over 2. So again, what do we notice? Very similar to yesterday's video. What do you notice if we look at the denominator? Well, remember cos squared plus sine squared for a particular angle is always the number 1. So you've actually got the number 1 on the bottom here. So this here is literally just the number 1. So this equals 1. So we've just got cos squared theta over 2 take away sine squared theta over 2 divided by 1. So that's just going to be cos squared theta over 2 take away sine squared theta over 2. Okay, so now how can we go from here? Where can we go from here? So remember from the double angle formulas that we looked at in my double angle formula video. So remember that cos 2 theta is the same as cos squared theta take away sine squared theta. So remember, we looked at that formula in my double angle formula. You can check out, again, my video on double angle formulas in my trigonometry A-level playlist and also my A-level maths pure syllabus playlist. So we've got cos 2 theta is cos squared theta take away sine squared theta. So we can halve the angles in our arguments of our functions. And if we do that, so just halving all these angles, we get cos theta is equal to cos squared theta over 2 subtract sine squared theta over 2. So this is exactly the same as what we've got here in our result. So we know that this is just the same as cos theta. So therefore, so just write my theta and eta. So therefore, we've proved the result. So yeah, this fraction here, 1 minus tan squared theta over 2 divided by 1 plus tan squared theta over 2 is the same as cos theta. So again, this is not a result you need to know or need to learn, but it's good to know how you would prove this result in case you were asked to prove this result. So it's just really a case of using, again, your identity cos squared plus sine squared is 1. Doing a little trick by multiplying all of the terms by cos squared after changing this tan squared into sine squared over cos squared, and then remembering your double angle formulas and the fact that you can actually manipulate your double angle formulas by changing the arguments, by halving the angles in your arguments. So yeah, that's how you prove this formula. And yeah, that concludes today's video.